Welcome to our online chemistry class. Myself Mukesh Balkrishna Kharge from SSPMS Junior College, Shivajinagar, Pune 5. Our today's topic is electrochemistry. So first of all, we have to discuss one question. Do you know how does a dry cell generate electricity? So answer is a chemical reaction occur in it which generate the electricity. So thus the dry cell is a chemical energy source and chemical energy is converted into electrical energy. So all are familiar with electrolysis. So electrolysis is a breaking of an ionic compound by the passage of electricity. So when you pass the electricity through that ionic compound, it undergo broken. So breaking down of an electrolyte during the electrolysis is a chemical reaction, and that takes place when you pass the electricity through it. So here electrical energy is converted into chemical energy. Then another word that is the heading of this topic, that is electrochemistry. So it is the area of the chemistry which is concerned with interconversion of chemical and electrical energy. Then here we have to consider aqueous solution of some substances. So if we consider preparation of NaOH, we use manufacture of soap, detergent, papers by one process that is called as electrolysis of NaCl. So electrolysis means what? So all of you use some processes: electro refining for purification of metal, electroplating for coating of one metal is on the surface of another to avoid the rusting. So these processes are mainly electrochemical processes. Then all are familiar with one word, redox reaction, that you use in 11th standard. With the help of this redox reaction, we can generate the electricity by chemical reaction, and also for chemical reaction brought about by means of electricity. So these processes are carried out in an electrochemical cell. So our current research in electrochemistry is focused on designing the fuel cell. Then here we have to consider electric conduction. So all are familiar with word conductor. A charge transfer or flow of electricity occur through some substances that is called as conductors. There are two types of conductors. One is metallic conductor and another one is electrolytic conductor. Let us discuss metallic conduction and what is metallic conductor. So electric conduction through metals involve a direct flow of electron from one point to another. So the outermost electron of metal from conduction band, the electrons in conduction bands are free to move and hence flow under the influence of applied electric potential. So these metallic conductors are also known as electronic conductors. Now let us see the another type, that is electrolytic conduction, or it is also known as ionic conductions. So electrolytic conductions involve conduction of electric current by the movement of ion of the electrolyte. So now in your mind there is one question: what is electrolyte? So before that, the conduction through the electrolytic conductors involve transfer of matter from one part of the conductor to the another part. Then, to study that electrolytes, substances such as ionic salt, strong acids, strong bases, weak acids and weak bases, they are mainly acts as a electrolyte because they dissociate into their ions when dissolved in polar solvent such as water. Ionic solids dissociate into ions in the molten state. So for example, ionic solid such as KCl, potassium chloride, NaCl, sodium chloride, they if added in water, then they form their ions. Okay, when they are in molten state, they also prepare their ions. Then their strong acid like HCl, H2SO4, HNO3, when added in water, they give H plus ion and Cl minus ion, or SO4 2 minus ion, or NO3 1 minus ion, like these ions. Or when strong base like NaOH, it gives Na plus OH minus. Weak acid, acetic acid, CH3COH gives CH3CO minus and H plus ion. So these ions will be produced and conduction through these ions. That's why the solutions of these substances, these solutions are called as electrolyte. Then those substances which do not conduct the electricity, that is called as non-electrolyte because they do not dissociate in their aqueous solution. For example, sucrose and urea, they does not dissociate. So conduction of the electricity does not takes place through their aqueous solution. They are called as non-electrolyte. And if you measure the conductivity of this solution, it is nearly equal to the conductivity of water. But if you check the conductivity of aqueous solutions of electrolyte, it is higher than that of water. If you observe strong acids, strong bases and the salts, they dissociate completely into their aqueous solution. So this type of identification of electrolyte and non-electrolyte, this experiment you already performed in 10 standard. So one aqueous solution is given to you, two rods, graphite rods are placed in that, then one in between these two electrodes a switch, battery and a bulb is placed, and if we switch on the battery and if bulb close, then what you say, there is a conduction of electricity through this circuit and the solution is electrolyte. If bulb does not glow, this indicates that solution placed in your container is a non-electrolyte. Then weak acids and weak bases are weak electrolyte because they dissociate to very small extent in their aqueous solution. Then next one is the electrical conductance of solution. So one law is very famous and that is Ohm's law. The electrical resistance R of a conductor is equal to the electrical potential difference denoted by capital V divided by the electric current I. So R is the resistance which is equal to V by I. It is the ratio of potential difference to the electric current. So potential difference is measured in volt in SI unit while current is measured in ampere. So what is the unit of your resistance? It is ohm. okay, and it is the Greek letter omega. So omega or ohm is equal to volt per ampere. Then one more term is there, that is electrical conductance. It is denoted by G and it is nothing but reciprocal of resistance. So G is equal to 1 by R. So as ohm is the unit for resistance, your conductance is ohm inverse, or it is also known as mhos. Okay, so reverse word MHO S. So it is also denoted by Siemens. Okay, so that mhos word is not used in this syllabus, it is used in old syllabus. So ohm inverse. So what is ohm inverse? Ampere volt per volt, or C V inverse S inverse, where C represents the coulomb and which is the unit of electricity, which is related to the current strength in ampere and time in second. So 1 coulomb is equal to ampere second. Then your electrical resistance R of a conductor is directly proportional to its length and inversely proportional to area of cross section A. Thus R is directly proportional to L by A, or R is equal to rho into L by A. So rho is nothing but proportionality constant called as resistivity of that conductor. What is resistivity? It is the resistance of conductor of unit length and unit area of cross section. So when, if we write L is equal to 1 centimeter, A is equal to 1 centimeter square, then R is equal to rho into 1 divided by 1. So R is equal to rho, that is the rho is nothing but resistivity, is the resistance of conductor when length of that conductor is 1 centimeter, having area of cross section is 1 centimeter square. Then next is the conductivity denoted by K. So conductance G is equal to nothing but 1 by R, and R is directly proportional to length, inversely proportional to area of cross section. So G is equal to 1 by R, and it is nothing but 1 divided by L by A. So G is directly proportional to A by L, or G is equal to K into A by L. So where K is proportionality constant known as conductivity, and it is denoted by G. When we write G is equal to K if A is equal to 1 centimeter square and L is equal to 1 centimeter. So G is, that is your conductivity, K is the conductance of your conductor if length is 1 centimeter, having area of cross section is 1 centimeter square, that is unit. So conductivity is the electric conductance of the conductor of unit length and unit area of cross section. So in short, how will you write? The conductivity is the electric conductance of unit cube of material, and the conductivity of a solution of an electrolyte is called as electrolytic conductivity. And what is the unit? 1 meter cube, or in CJs it is 1 centimeter cube. So from equation 5.2 and 5.4, what do we write? K is equal to G into L by A. where G is 1 by R. So K is equal to 1 by R into L by A. So if we combine equation 5.3 and equation 5.5, what we get? K is equal to 1 upon rho. So rho is equal to R into A by L. So K is equal to 1 by rho. Okay. Then, so remember these formulas. It is useful for solving the numerical based on conductivity, resistivity, conductance, and resistance. So what is the unit? Length in SI and CGS, it is meter and centimeter. In area, meter square, centimeter square. Resistance, ohm in both system. Conductivity, ohm inverse, meter inverse, ohm inverse, centimeter inverse, or ohm inverse is nothing but Siemens. Here. Then next is molar conductivity. The electrolytic conductivity is now not suitable for comparing the conductivities of different solutions, because the conductivity of solution depends on number of ions present in unit volume of the solution. The solution of higher concentration contains more number of ions and exhibit higher conductivity than the solution of lower concentration, because in lower concentration number of ions will be less. So it is not easy to compare the conductivity of different solution or the solutions which have different concentrations. So there should be same concentration, then we can compare the conductivity, and for that purpose a new term was derived by a scientist, which is a German physicist, KHARGE, in 1880, and that term is denoted by capital lambda, and the term is called as molar conductivity. So molar conductivity of an electrolytic solution is the electrolytic conductivity K divided by its molar concentration C. So capital lambda is equal to K divided by C. So what is the unit of K? It is Siemens per meter, and that of concentration is moles per meter cube. Hence SI unit of molar conductivity is Siemens meter square per mole, and CGS unit is ohm inverse or Siemens centimeter square per mole. Now what is the significance of this molar conductivity? So consider volume of solution containing 1 mole of that dissolved electrolyte. Suppose that solution is placed between two parallel electrodes which is 1 centimeter apart and large enough is to accommodate the solution. Then the electrical conductance exhibited by this solution is called as molar conductivity. So in short, we can say that molar conductivity is the electrical conductance generated by all the ions in 1 mole of the electrolyte. Then what is the relationship between conductivity K and molar conductivity? So conductivity K is the electrical conductance of 1 centimeter solution. If V is the volume of solution in centimeter cube containing 1 mole of dissolved electrolyte, its electrical conductance is capital lambda. So in each 1 centimeter portion in the volume V has conductance K, hence total conductance of V centimeter cube is, for 1 centimeter cube the conductance is K, for V volume, that is V centimeter cube, conductance is K into V, and that is nothing but molar conductance. Okay, because we consider that in that V centimeter cube solution the 1 mole of electrolyte is dissolved. So capital lambda is equal to K into V. Now we know that concentration is C and unit is mole per liter or mole per dm cube. Now if we divide this by 1000, so 1 liter is equal to 1000 centimeter cube. So 1000 centimeter cube divided by per liter, into per liter or divided by liter. So that liter get cancelled. So what is the remain? It is C divided by 1000 mole per centimeter cube. So here V is the volume of solution in centimeter cube containing 1 mole of that electrolyte is the reciprocal of the solution concentration. So V is nothing but reciprocal of its concentration, 1000 divided by C centimeter cube per mole. So if we substitute this value of V in this equation, lambda is equal to K into V. So what do you write? Lambda is equal to 1000 K divided by C. Okay. Which is the equation 5.9. So let us discuss one numerical. The molar conductivity of 0.05 molar barium chloride solution at 25 degrees centigrade is 223 ohm inverse centimeter square per mole. What is its conductivity? So here is the formula. Molar conductivity lambda is equal to 1000 into K divided by C, or we can rearrange same formula is equal to like this: K is equal to lambda into C divided by 1000. Which are the given thing that we have to write? Lambda is molar conductivity. It is given 223 ohm inverse centimeter square per mole. C is the concentration. Here it is 0.05 molar and divided by 1000. Substitute the values and calculate the answer. So what do you write? K is equal to 223 ohm inverse centimeter square per mole into 0.05 mole per liter divided by 1000 centimeter cube per liter. So your answer is 0.01115 ohm inverse centimeter inverse. Thank you for watching my video. Visit my YouTube channel KHARGE. Thank you very much.